Hey everyone, and thank you for coming to our second DataFest R workshop. We have a really good turnout today, which is really exciting. And so today's workshop, as you'll learn, is about data wrangling and about manipulating very large data sets, the kinds of data sets that you'll see at DataFest. And I also wanted to make a brief announcement about the workshop that we have coming next week. That workshop is going to be on data visualization. And it's actually going to be in MS 4000A, so we got a really big room for that one. So come out to that as well, and yeah, I'll turn it over to Professor Lew, who has very graciously volunteered her time for this.
That's a good start, right? I just want to talk to you about basically making data manageable, especially large and complex data. We're going to look at reading data, modifying it, and splitting, subsetting, and merging. And you should stop me with questions if you want. I'm just going to take you through what I think of as 8 tasks that are going to be involved in DataFest, thinking about what the data probably looks like, having seen it over the years. Let's talk about reading data, because one of the biggest mistakes I saw at DataFest was reading the data too many times. Okay, you should read the raw data once. When I'm talking about raw data, when I'm talking about raw data, I mean unprocessed. That is the form that the client or the person supplying data is going to give to you that night. That's raw. Okay, I don't know what form it's going to come in. Does anyone have any clue? They haven't said a thing. Okay, my guess is just going to be a CSV file, and that's what I provided for you tonight. Okay, and read it once. So the one I'm using as an example, I know of a ton of stuff, right? Is crimes. It's got a lot of extra characters, and we'll talk about that. Crimes 2001 to the present. It's a 1.4 gigabyte file, and if you got here early, you downloaded it. If you didn't, good luck. You can download it now, but it's quite large. All right, let's talk about the reading of raw data. Okay, raw data is meant to be read just once. What you want to do is when you get it, read it in. All right. And it's time consuming, alrighty, and it's resource intensive. Basically, your computer's resources will be fully devoted to pulling this thing into memory when you read it for the very first time. And you don't want to be doing this over and over again. And that's what I mean. One of the biggest mistakes I'd see is suppose somebody's computer crashed during modeling something in DataFest, and all they've been doing is reading the original and leave it in memory and in modeling. They would have to reread it. Now, it took this computer about 6 minutes to read it, the 1 gigabyte file. I suspect the files that you'll be given are larger, and you'll be given more of them, okay? So you've got to really manage it well. This computer I'm sitting at took 6 minutes. It has 16 gig of memory for a laptop, okay? It's a lot for a laptop. They need it, because I'm working with data sets this size. Let me give you some pointers for that night. Okay, when I pull in, so if you try pulling it in, it gives you this weird long name, okay, with extra characters in it. There are a couple of things I'd like you to look at. The file will probably, with all likelihood, have a heading, because they're nice to you. They'll set it up that way. So make sure you click heading yes, give it a simpler name, and keep the strings as factors. And I'll explain why, all right? And reading it in this way worked just fine for me. As I said, it took about 6 minutes for this computer to read it. It's a 3-year-old MacBook Pro, but it's got a lot of memory on it. Okay, I've given a short name. I'm going to keep strings as factors. I would recommend you do that. Now, if you know how to write the read CSV command straight, you should do that. Okay, so when I mean writing it straight, this is what it looked like if you were to just type it in, because I know some of you are very talented. This is how you do it. And I know there are packages out there called data tables and dplyr. I'll get to that at the end. I just do it my way because I'm fast with it, okay? So I don't have to think too hard about this. So you should save your converted data. So this is you should save your converted data to an R workspace immediately. So you read it in. I'm using read CSV. I don't have any options on it. I'm leaving strings as factors, and the first row is assumed to be a header. And you could take a look at it. View is slow, all right, because it is, again, it's a somewhat of a resource-intensive function. You might choose something else, but here I'm going to save it. Some of you have never saved an R workspace before, so here's your introduction to it. This is what I mean by saving it. You could save it. I've given it a much shorter name. And I've given an identifier so I know it's our data set. Okay, once it's saved, it only took about 7 seconds to read it back into R. Okay? So remember, I've got a relatively fast computer, even though it's an older MacBook Pro. It's got a lot of memory. R uses all the memory up. 6 minutes to read, it could be 20 minutes on some other computers in here. By the way, if you think you're going to use a MacBook Air in this competition, you're not doing any of the programming or data wrangling. It won't work. I've seen them crash at prior competitions. I've seen them, I mean, it didn't burn, but it definitely crashed. But it only took 7 seconds to read. So you save it, and then it's about finding it later. This is what it looks like on my hard drive. Now notice, it was 1.4 gigabytes. And now it's about 250, depending on your system. So it's dropped down tremendously, okay? At 250, 260 megabytes, it's at least manageable in your memory. Because now you have 8 gig, maybe 2 gig to 4 gig are being devoted to your system and to other things that you're running. Everyone seemed to be running a ton of other things. That's also, we'll talk about that later, but it's going to eat into your available resources, okay? Now, so it's been saved to disk using that save function. Couple of notes in here. Strings as factors equals true. Workspace is 260 for me. If we had used my favorite, strings as factors equals false, the workspace is 318 megabytes. Okay? So that may matter for some of you. That may be the difference between the computer crawling when you're trying to do something and it being responsive. Okay? Because it's a significant drop. Okay? It's just because characters take more space. So I'm saying it's got to be factors, and you've got to know how to manipulate the factors well that night, okay? Task number 2. Okay, any questions on task 1? My guess it's going to be read CSV. If it's not, send me an email, I'll send you the code to read it in fast. But my guess, it's going to be some form of read CSV, okay? Sir?
Why is the raw data much larger than the data that you transfer into?
R stores it extremely compactly. That's why I said the first thing you should do is read it in, write it back out. And then I would exit RStudio for a number of reasons. Mostly, I think there's a mix, at least on mine, I think a serious memory need. So just blow everything out, restart it, and read in. Only took a few seconds for me. It might take a little longer for you, but it's going to be a lot faster. All right? And it's tighter, only 260 meg, maybe. Okay? If you dump some variable, it's going to get even smaller. And then the speed becomes of the essence. Okay. Other questions? So good question. All right. Your second test, you got to get to know the data quickly. What I mean is you've got to get a sense for it, a sense of size, a sense of what is available to you, right? Let me illustrate that fuller. All right, the successful teams are probably going to nail it down by Saturday night. In other words, sometime Saturday night they will have gotten their idea, done some modeling perhaps, and are ready to put it all together. Sometime around around midnight, sometime early Sunday morning, it's been done. But you've got to take the time to get to know the data a little bit. Otherwise, you'll go down what I think are dead ends. You know, you go down a path and it doesn't work because there weren't enough observations to support what you're trying to say. So let me show you a couple of things. Okay, summary is really fast. I mean, I timed it here. System.time is a timing function. So if you're wondering between now and DataFest, and you're sitting around with like, if you want like a 9 gigabyte file, I probably have one laying around somewhere for you. It's not probably going to be that large for you, but they're out there. You can time it, see how long certain things take. And I'm doing that because, again, I'm showing you how to manage data the way I do it. There are faster ways. So I was talking, is Freddie here tonight? Freddie, like we were talking, saying it's 10 times faster if you use certain other packages. Okay? But on the other hand, I don't have to think too hard about it. It comes very natural to me to do. So what I lose one place, I might make up a different way. So you should do what you're comfortable. Summary, it's going to blow through and give you distributions for all the variables. And because you left it as factor, things like, what am I saying? Like primary type, like these character variables show up and you can sort of see it's tabling it for you. There's sort of a couple of nice things about summary. It's going to tell you how many are missing. All right, like look at this one, community area. I got 600,000 missing in here. Okay, I got like 5 million observations, but still I've got a significant amount missing. And you need a sense of that almost right away. And just to give you an idea of maybe what will and what won't work, all right? And you'll see a little bit more as we go on, but summary is fast, okay? So summary, complete summary statistics. However, it rounds severely, so don't use these numbers for anything else. Use it for like a quick view. Like, in other words, if you had this screen and these are your DataFest variables, now you have some kind of like what we call codebook. It has the variable names, it has a bit of a distribution, it tells you something about the variables there, something more than just pure numbers. Okay? It will table factors and will reveal the NAs, or the number of them. And that's what I'm showing you this image. Okay, another way to get to know your data quickly. Structure, this took like a second to run, okay? All right, it tells me how many observations, how many variables, and the order of the variables, and it's giving me some sense of what I've got factor-wise. Now what's nice in here that summary didn't show is I know how many levels, that means how many unique values are here in these factors. So again, it's about, maybe simplifying or making this more workable, because you're telling your story, and maybe you want to do something with the type of crime. Okay, so there are obviously two types of crime in here. There you have something called the primary type that only has 37 levels, and then the description is a fuller thing that is very specific about what crime occurred. Okay, with 367 levels, it's kind of hard to like make a table or a graphic. It's going to be much harder, much more challenging. It's still doable, but you're going to have to be much more clever. On the other hand, with primary type, 37 levels, I think I'll start there. Or at least start to take a look at the type of issues around the data set that night. Okay? So it just gives you, again, a quick sense. And that's all I'm trying to do with task number 2. You got to get to know the data quickly. Like by the end of that, well, say by midnight Friday. I would like, ideally, you should have a sense of what's in there and start to build a story. Like, what could we do with this data? Okay, structure, variable type, size, the data frame, factor level information, variable names, and position. Get to know your data quickly. Names, head, and tail, okay? Again, just to get a sense, because you don't want to be looking at all 5 million observations. Head and tail will give you 6. All right, you could ask for more. Again, I'm just saying get a feeling for the data. Now, there will be a presenter on that evening around 6 o'clock. The client will tell you about the data they provided for you. It will go by you so quickly, right, that you really just want to dig in and need to start looking at it. Okay, so names is really, these are all like 1 second, all right? Names tells you what are your variable names that you can work with. If you're going to rename something, I'll show you how to do it later, okay? Head, view, tail is another way. And so looking at head and tail right away, I could see that this is organized. The oldest ones were from 2001. The observations at the top of the file were from 2014. So there was some order in there that I would have to like recognize or deal with. Levels. You can find out what levels are available to you with the levels function. And these are for factors. All right, so I'm showing you levels. Crime arrest, it just has 2, whereas primary type, it has a bunch. This, again, serves as your code book. Like, what kind of things could we study or look at in here? Okay. Any questions on task 2? Task 2 is the fast stuff. Just get a feel for it. You can probably screen capture your results or something and store them or email them to yourself, but have it there as a reference. Task number 3, saving objects. You can retrieve them later. So we saved the data set, but there are lots of other things you can save. You can save your summary. You can pretty much save anything you want in R, all right? It's just knowing that you could do it. So Chi's sum is just my summary for Chi crimes, and it's an exact duplicate. So I could mail this object. I can do all sorts of things. Same thing here. I could save the levels. So now I have, again, a code book, something I can share, discuss, whatever. But, it goes, because like, I'm not sure what the setup looks like this year, but in the older DataFest, there would be maybe some lounging type of chairs that you could just relax on. And so maybe you don't want to be sitting in a seat like this and working on a computer, you want to just walk away. And maybe you want to keep your computer plugged in, and this is a good time to have other things you can look at. Like this, you can look on your phone screen or your tablet screen. You don't need to be a laptop. To think about what you're facing. Okay, so task 3 was saving objects. There are lots of things you can save. You could try it. You can save tables, and those are handy. All right, speaking of tables, we're in task 4. All right, tabling and sorting. Okay. Your sorted tables can be saved. Any table can be saved. The sorted ones are useful, because what sorted tells me is, okay, I saw the levels in the previous slides, but sorted tells me which one was the most common. So there were like well over 1 million thefts in the Chicago crime. So obviously when batteries, like getting hit. this will tell you right away, like, if some of your ideas will have enough data to support it. You could probably see a tabling of some of the factors. And this will work for any factor. Again, it's quite fast. The emphasis for me was speed and resource conservation in this workshop. This one, there are 367 kinds here. This is where a sort, I can't even see the first one. This is where a table of sorts is useful, because now I can pick it out very quickly, okay? In other words, if you've got a lot of levels of a factor, think about tabling and then sorting it so that this will scroll by you and you'll see the bottom of the table. All these codes are present in the R script that I uploaded to the site, okay? Sidebar. Let me take a break from those tasks on the sidebar. This came up, I couldn't think of a good thing to call it. Numeric is out there, and also is.na. These are handy. Let me show you how handy Numeric is. In our crimes data set, so one thing you would notice if you looked at head, where is that? Is that I've got numeric variables and I've got character variables and they're mixed up next to each other. This makes it kind of hard to run a correlation. And if you have a lot of variables, my guess is you're not going to have 30, however many I have here, 20. You might have 250. Okay? And so picking through it would be a pain in the butt. You don't want to type in all these number sequences. This is how you want to do it. You could read this from the inside out, but what's going is I'm doing a simple apply. I'm going to loop through the vectors in Chicago crimes. And for each one, I'm going to ask, is it numeric or not? Okay? And basically, it's going to save those numeric ones. And what I want, so what's going on is I've got the data frame, and I'm extracting only the numeric vectors. Okay? And then this is nested with a correlation. And I'm going to use the complete observations. Complete observations is going to be a lot faster than using pairwise, especially if you have 5 million, okay? You got to think speed. So, yeah, you might say, well, wait a minute, complete observations, you're going to be losing a lot of variables. I will. You're going to have to double check things, but at least, I said, the emphasis is on speed and that first night. Because you're going to have to come up with your ideas very quickly, all right? Like, when I say very quickly, 18 to 24 hours, and you need sleep in there, too. Okay. So you want to be, you want to have a very good sense of the data set within, I'm saying hours. You don't have weeks, days to do it. You've only got a little bit of time. And so with a correlation, I can now see, maybe what's interesting and what's not. Like maybe it narrows it down for you, reduces the amount of information I have to look at. So you can imagine about 250 mixed character numeric. I want a system like this and not trying to pick through and say column number, 149 is numeric and 150 is not, right? And you have to think smart about this. Have R plow through and find the numeric variables for you. And then, of course, you could always save it to a new data frame. You could have a total data frame of numeric variables if you needed it. That's just an extension of this, all right? Is.na would work the same way. You could always remove from your data set any kind of, anything that had an NA. That's kind of severe, but it's doable, okay? So many functions, the reason of doing this, many functions use only certain types of variables. That's what you read the documentation for, all right? Like core is only going to want numeric. Right, I guess it could use factor, but off the top of my head I don't remember. But they want certain types, and you can quickly extract the right type. That's the function of the slide. Say, have that in mind, because that will save you time. Sidebar, memory issues, okay? So here I am. I don't know what you use, but I think you should have a memory manager that day, okay? Because this leaks. I don't have a better way to put it. Memory leaks, okay? Which means even though you erased it, even though you might have quit out of it, it doesn't mean it let go of the resources. And so I was seeing people computers started crashing around 1, 2 in the morning when I arrived. Okay? So And you can get around that. I don't even know what this one is called, but it tells me where I'm using up memory, and it tells me how much, and I can click the button, and it's going to clean it up a bit for me. All right. So with data, I deleted it, and it was still right, hogging up 6 gigabytes, and then at least I got a little bit from it. It's 5.5 or so. Okay. Questions on that? So those are two these are nice little things that you can install now. Right? You don't have to wait till that night. Okay, task 5, growing your data frames. Okay, because you got the data, and I'm saying you've read in some data, you've saved it, you've gotten a good look at it, like a good strong look at it. Maybe you're starting some basic tabling, and at the same time, I would want you to have some ideas in mind. Okay, so like in other words, if it was a crime, about 5 years ago, the DataFest data was crime data, and one of the winning teams. What did they use? One of the winning teams had used external data, which was bus stop information. And what they want to see were what crimes occur around bus stops, and could there be better policing around them, in the hopes of winning something like an insight prize. Okay? And so that came to them on the first night. It was just the logistics of putting that together over the next 24 hours is what it took. Okay? So the reading's going to be easy, saving it. The fast part that I just showed you, it's just to give you that little time where you can sit together as a team and talk about things. Okay, growing your data frames. I actually don't recommend that you attach. I didn't do any time trials with attach. I just don't use it as a rule because it creates issues for me, but it might not create issues for you at DataFest. But what I would suggest is that I recommend if you're creating new variables, you're going to be creating new variables for this, or modifying old ones to add them to your existing data frame and then subset. All right, if your data frames get too large, you're not going to need every variable that you have. If they give you 250 of them, you definitely need it. All right, so you make some decisions of what to cut. That's why saving the whole thing and then subsetting, and I'll show you how to subset in one of these tasks, would be the way to go. Okay. All right, let's just take a quick look. I looked at, okay, this is a good task. This is my guess is what you're going to have as one of your variables. So I just want to show you what child crimes looks like. And one of the variables is date. Okay, and I would be willing to bet, I don't know, at least $100 if there's a date variable in this data set that you get. All right, so I just want to show you how much time, it was less than a minute, to create my date, which is a new variable. And so if you've not seen this syntax before, forget the system time, that's just doing a timing for me, okay? But what I'm doing is, I am going to take the data frame child crimes and extract, it's a weird idea, I'm extracting my date, which doesn't exist yet, okay? It exists now that I'm going to name it, and this is going to get the result of, I'm going to convert the existing child crimes date, which is a factor, this curving sort is a factor, with the strp time function. And the trick with this is that you just need to get the format right, okay? And this format is a very common timestamp. In other words, you know, like when you enroll in a class in Murphy Hall, there's a timestamp to say what time it happened. I've seen the data, so I can say that. So this data, similar idea. When a crime was reported, there's a timestamp applied. And I bet you, given the rumors I've heard about your data set, that there's a timestamp, much like this. So you just have, so you would look up the documentation on dates and times, but the format here would have to match the way the data looks. So looking at the date variable, it's in the upper left. I am asking for percentage lowercase m is a numeric month, 01 through 12. And then there's a slash here, maybe hard for you to see in the back row, but again, I gave you the script. There's a slash in there because it matches the slash in the date. Percentage D for date numeric from 1 to 31. Percentage capital Y is telling R that it's a 4-digit year. Okay. Then there's a space because there's a space in the data. So your statement, your format has got to match that timestamp exactly. Now, what I would recommend, and we'll talk about it, is I would actually recommend, and I should have written this week, I should have been thinking more like, you could take, it says head here. You could say, let me write it. You could say something like this. Junk, okay, gets, head, child crimes. Okay. it didn't actually take that long to create this new date variable, but this would be really fast. It only has 6 observations. You can make a new data set called junk, and you could do all your transformations. You could try your time variable format on this little thing. And then when you think you're ready to go, run it on the full one. So I'm sorry I didn't think about that for you, but that's how you could make really easily a new copy of your data set, okay? Just the first 6 lines. Alrighty, and so this one then, space, and then percentage I and P go together. P is an AM PM marker. I said modern timestamps, they almost all have AM PM. So percentage I would always have a percentage P. If there's no AM PM, use percentage H, stands for hour. And then colon, just like it does, capital M is minutes, capital S is seconds, all right? We run it, now take a look, I'm doing head chi crimes. It'll become the last variable, just growing it horizontally. It'll become the last variable in your data set. If it's missing, it would be NA, but otherwise, this should check. So you'd want to look at the original and the new. That's why running it on a small one would work, and then just examining those 2 columns. But here's my date, the way R understands time and date, okay? That's how you could create a new variable. So anything could go in this part. So when you're creating a new variable, right, I'm gonna write that without all the extra. So if it's called Chi Crime for Chicago, $, and you name it, okay, your variable, and then whatever. It could be the log of something else. Log, Chi Crimes. $, full. Okay. You could just do that. So any variant, this one happens to show you how to convert a time. As I said, I'm only bet $100, right? Then there'll be a time variable in this one. They always seem to have one. Okay, and then just showing you down here, I'm just looking at a summary of chi crimes for those 2 columns, the original date and the new date, because what I wanted you to see is this one is being stored as a factor. All right, and it's tabling it. This my date is being stored as a numeric variable. All right. I don't have the time to tell you how a time variable works in R. You can always read about it, but I'll just say it's now numeric. This allows you to perform math on it. Okay. So you can compute things like, should be next slide. All right. Chances are DataFest will have a timestamp. Looks a lot like the date in this database. Use an AM/PM identifier. Use the I. Not use an H. If you don't convert a date, whether it's factor or character, to an R date, you will not be able to perform computations with it, like elapsed time. Like maybe the data, like let's just look at the crime data. A question could be, could we predict the next crime? Like maybe in a small area, given the previous intervals. So maybe it's the case you have a theory about every so often you should expect the crime. And maybe you could assign probabilities to see how well you could predict the timing of the next crime. You wouldn't be able to do that if you don't convert the time variable out. You need the time variable to work like a number. And it does because in conversion, R is just mapping times to a number line. Right? And you're just doing some simple math and you're computing elapsed time. Questions on that? That's going to be there, I promise. If it's not there, you can make fun of me when I tour your facility. You're so polite. Let's go on. All right, let us talk about subsetting by sampling. So I showed you a really quick and dirty subset. Let's just take the first 6 lines, or the last 6 lines if you use tail. And you can always adjust tail so it's longer, so you can say n equals like 200 and have the first 200 rows or something. But let's look at subsetting by sampling. After all, you are statisticians, or want to be statisticians. And you might think, well, because it is obviously ordered from oldest to newest crimes from bottom to top, we should randomly sample throughout this huge database, all right, which is reasonable. Okay, so you should set a seed. It will always ensure the exact same sample in case you have to redo it for some reason, or in case you want to share it with your colleagues. They'll have the exact copy. You could get away without doing it at DataFest, but it doesn't hurt because there are some other good things about it. If you randomly sample, here I'll give you a good example. If you were to randomly sample in order to create a training data set and a test data set, what you might want to know is what the training data set had in it compositionally, and then have the observations that didn't get into your training data set to be in your test data set. In other words, you want to do something like 50-50 split, and you want to make sure it's exact. You might do it the following way. In this case, let's just take a quick look. chi crimes is the data frame again. And I'm going to, it says extract, but I'm going to sample the length of the first vector. All right, so that's basically however many. So it's dynamic. If I have something not as long, it doesn't matter, right? I didn't hard code the number. Comma, 100,000. So this can grab a sample of size 100,000 from my 5 million or so rows. And then there's a little comma after that, means keep all the columns. Right? So I could sample and whatever number I want from the entire data set. And then it's going to get, it goes into little chi, or little chi. So little chi, which is a smaller subset, gets the result of sampling on the first vector. And we're just using it, all we're doing is we're using the length of it. In other words, a sample command, sorry, no, I'm looking at some confused face. A sample command says basically sample, and then you can put a single value in here, let's say 1,000. And then you can put another, and then the second value would be the sample size. So if I said 7, it would choose 7 from a vector of 1 to 1,000. Okay, so this is basically implying a vector from 1 to like 5 million something around. Okay, and we can take a look at little chi just to make sure. 100,000 observations, 23 variables. It's just a copy. Notice the format of my date. It's very different. I recognize this to be an R date. And it is storing the information basically in pieces, well, not quite pieces. It's a single value, and we can extract things like day of the week, hour of the day. This becomes a very handy variable when you're looking for patterns in the data, right? Because you might not have enough data to look at cycles over months or years, but you may have enough data to look at daily type of cycles, right? And you would need this to help you. So once it exists in this format, you can pull whether or not, what day of the week it is, what week of the year it is, what, all kinds of things, right, are possible here. And then you can count computer elapsed time. All right, other things. Let's keep going. Questions? All right. You can also subset by indexing on both the rows and the columns. So this previous one, I could have also, at the point where there's a comma and that right square bracket, I could have put in a vector of values and thereby select only those particular variables for analysis. I mean, looking at what I'm given here, I mean, if this was our DataFest data set, there are a lot of things I wouldn't use. Okay, a lot of things I wouldn't use. So here, this is just to sort of keep it kind of clean. So little chi 2 is going to get little chi, and this is extract all the rows. That's what the blank is, comma, and then these specific columns. And you would use the C function, the concatenate function. You notice it doesn't have to be in any order. It says 1 to 2. I could have just put 1 comma 2. And then it grabs the 23rd one. And you could reorder your data frame in this way to maybe make it make more sense to you or easier to see. All right, 12, 11, 10. And that's it. So it's going to be exactly how you specify it. So if you go back and you compare the other slides, you'll see that I have moved my date way up to the front. And I've gotten rid of the other date. And then I've just sort of organized the rest the way I see fit. You can also, of course, index or subset on both the row and the column. So remember, by convention, data frame, junk, R, comma, C. And so we can operate on both sides. In this case here, this is how I would ask for it. So chi-crimes name the data frame, extract, where domestic, chi-crimes domestic equals true. Equal equals true. People ask me this all the time. Equal equal is not assignment, you're doing comparison operator. You want to know if this value was, if that was the value, you're going to keep it. If so, then your vector of variables you wish to keep. Okay, we'll just take a quick look. Always check your work, all right? And we can see, yeah, we've just got domestic violence cases and domestic visits by the police to some house. All right, so you can subset on rows. So you can obviously do something like sample and subset. All right, in other words, sample and get whatever row, column vectors you want. And you can also make the row a little more, I guess I have a duplicate side in here, so I'm sorry. So we use C to customize the order of an object. All right. Concatenate function is handy. You can also put in multiple conditions. All right, so here's one. Little chi 2 gets chi crimes, extract chi crimes, extract year is greater than 2010. So that's how I would write, I just want crimes that occurred after 2010. And there's an and, so I want another condition. This says high crimes district, and I'm using an in operator here. In is better used in other ways, because I could have just written, say, equals or something, but what in is handy. I'll explain it to you in a sec. Let me just finish this up. The district has to be one of those three values only, 7, 11, or 8. And then comma, and then I want those same columns, all right, and we can take a look. All right, the in operator is super handy because what it does is you use it, it's basically, I think of it as like it has to be in or include. This is useful. Let's suppose you had a variable that's like, I'll call it junk $sign type. And then this is great when you want to extract, let's suppose type where assault and sex offense. And any number of character variables or factors in here, all right? What this allows you to do, so, damage or something. So it allows you to just, you could use create some kind of character vector or some vector of factors or even a numeric vector and only extract those that match or that are in that set, okay? So it's a great way of extracting a lot of character information, all right? So in other words, I don't know if you wanted, let's suppose race is one of your variables and you wanted, say, Asians, and you wanted Hispanics, and you wanted people who said they were other. That would be how I would pull it. I would say, okay, subset it if race was in Asian, Black, Hispanic, say. That's the use of an in operator. It's, because I'm trying to think of like, you just write, you want one pass, one line, all right? You don't want to do things in little steps here because you've got this big data set swirling around in memory. You don't want to read and reread it. You basically want to do these good passes where you're getting a lot done, or in as little time as possible. Okay, questions? That one always like ties people in knots. Any questions on conditioning, sir?
So with the in operator that you have, you could write crimes, $district, equal 7, and then another condition, crimes, $district, equal 11, and 8, but that just does it all in one.
That does all in one. And I haven't timed it. I think it's considerably faster because it doesn't have to keep passing. I'll say it does this at once. Like it's searching for this vector as it's marching through the data set. It's not sort of looping through and looking at the first condition, looking at the second condition, looking at the third condition. That's why I'm suggesting this as a way of, you know, we can all do the big stuff. I'm suggesting that these are the little tweaks that may help, all right? Other questions on that? I mean, you guys can time it. That's why I gave you the system time thing. You can try these. I mean, honestly, my methods here could be made a lot faster. We'll get to that at the end. Okay, task number 7. This is probably for sure going to happen to some of you. It may not happen to all of you, but for sure. You're going to be combining data sets somehow, okay? Somehow. Either your team is going to decide, let's do the best use of external data question, all right? So, as I said, in a previous iteration, so a team had won because they had all this location, notice there's location information on these crime data, because usually the police want to know where did it happen. And so they also had scraped the web and pulled all these bus stop data from like the metropolitan transportation. And they merged them, they combined the data sets so they knew which bus stop was closest to which crime. You could just do a little math and you could just do as a crow flies. What is the closest, when I say crow flies, like a straight line, what is the closest bus stop to this particular crime? Okay, and that's all they really did, and it just attaches that this bus stop's here and so forth, so then they could map it ultimately. All right, so before combining, as I said, in here, I know on that night there will be teams that have to combine. Maybe not all of you, but definitely some. Have a picture in mind. All right, so I searched for a picture for you. Okay? In this particular picture, notice both the main data set and the appended data set both have the same exact variables, so we just stack them, all right, or append them. And so let's look at an append, because I don't know what form your data will take. The other thing you might do, and if I got time I'll talk about at the end, is you may cut up your data set and then you wind up recombining it in this manner. Okay, in other words, cutting it up by row, maybe like 1 million per data frame. Use RBind. That works really well for me. All right, so let's see what I have here. I'm showing you what the data set looks like as a result. It's not really useful. What I want you to see is down here. Sorry. I'm reading in, this is the LAPD data set. Someone's using this for 141 this quarter, but I'm reading it in. It's in my downloads directory, and I've read it in. And again, no strings as factors equals false. Everything's going to be all the characters are going to be factors, and it's assuming I've got a header. We can take a view of it as a view is slow, but these data sets aren't really that big compared to the Chicago one. And I got it for 2014 as well. Notice I give them much simpler names. No special characters. I usually keep one case or another. I don't usually mix case. And then RBind will stack it, and it does it in the order that it sees it, and you could do more than just 2, all right? So it grabs LAPD 2013, and then it's just going to attach LAPD 2014 to it. And if you had additional data frames that had the same structure, you would just add them. Now, you could have data frames with slightly different structure. In other words, if 20 out of 21 variables were the same, you could still append them, except that you'd have a vector of missing for the one that's not matching. But if they're totally different, it's not an append, it's something else. Okay, so in here, there should be a lot of overlap, if not complete overlap, of the columns. And all you're doing is you're just building it. And so I could put a dozen of these here. Doesn't matter. You probably won't have a dozen, but my guess is it'll give you at least 2 data sets to work with. That seems to be a trend in there. Questions on that?
So does the RBind automatically search for the matching
Yes.
variables?
So it doesn't have to, so he asked a good question, does it have to be in the correct column order? No. It'll search for matching names, okay? But it will use the structure of the first data frame that you put down. So that will decide the structure of subsequent, of the file subsequently, okay? And then we can take a look at the far upper right. So I've got the 3 databases, LAPD 2013, LAPD 2014. And then if you look, you just do some simple math. That's how we come up with almost 500,000 crimes over those 2 years, okay? So that's your check though, did my append work? I mean, it should sum up. This is a different type of combining files. I'm going to have a picture in mind. This is a match merge. And this is how the bus stop that went external data, or like last year was the energy one, right? Okay, so James and his partner merged temperature data back to the city. So they went and got weather data, and then they matched some city name. And so they do what we call match merge. In other words, R is looking through some column, in their case was city names, and then they had a city and temperature data, and this is how they put it together. So we could join or merge, and it says 2 tables by horse name. I just stole this from somebody's website on the internet. So horse name is in both. We're going to use that as our key. It should ideally be unique. Okay. So that's one that you got to look out for. Make sure if you're going to do this type of merging, if you have unique identifiers to do it. If you don't have one, make one. If you say, what do you mean make one? You could do it because combinations of variables. You might just concatenate or paste them together to come up with an ID number. Or assign it. Just number them and say this is the ID. And make them unique in some way, shape, or form. Okay? So we could, the goal here, so looking at this picture, right, would be to create a new file. So this is what I'm going to do for you. I'm going to show you a match merge. We're going to create a new file that basically is a school data set. It's a lot smaller. And what I want is the number of crimes committed in its police district. So if a school exists, there's a police district that it sits in. And I want to know how many crimes occurred in that police district. So really, I'm wanting a school data set with some additional crime information attached since 2010. So I want to see something. So as I said, you want to have it in your mind what this thing should look like ultimately. School name, location information, and number of crimes. That's really, in the simplest form, what I'd like to see. I can have other variables, but at heart, I should have these 3 tables. Okay, so there's some steps to doing this type of merge. Notice I'm spending a lot more time on this type than on the append. Appends are very straightforward. These are not. Okay, you need to have your school data ready by converting it to R. So all your data sets have got to exist in R. So again, if they give you like 4 data sets, what is it now, 2 Fridays from now? if they, 3 Fridays, if they give you 4 data sets, you've got to prepare to have like 4 converted to R, especially if you're putting it together. And then only keeping the columns of interest. That's what I would do, because otherwise these things get too big. You might aggregate the police data set and totals per district, because again, what you wanted to see was the number of crimes in each police district. So you're going to need to somehow aggregate the police data, because the police data doesn't exist that way. The police data exists as individual crimes. But now we're wanting it to be some total crimes by area. So we need to clean it, we need to aggregate it to get it there. And we need to clean it up to make it conform. Maybe naming conventions are wrong. This is where you learn to rename. Maybe I want to create new variables. Then finally, you can merge. You issue the merge command. Merge file A, file B, by equals key. With base R, you can only merge 2 files at a time. And it's the A file, or it's basically the X file, the Y file, and then by a key. And the key will link the 2 files. So the key should be unique. If you don't have a unique key, you've got rather unpredictable matching. The key should be unique. If you don't have one, make one from what you've got, right? And the key links the 2 files together. All right, so let's take a look. Match merging. These are the schools. So I have a data set, and I uploaded it to the location Spencer provided, which are Chicago schools. So these are a bunch of elementary schools. You don't need to know much more than that. There's the name of the school. And then this is a sidebar. I'm going to aggregate data that will give us the count of crimes per district. I'm sorry I didn't make this larger, but there's the command here. So let's see what's happening. I've got the Chicago crimes data set, and I'm going to use tapply, or it's basically a table apply. I guess that's what they mean by it. But I'm going to tapply by year, all right? So I'm using year as the variable, and I'm going to group it by district. So the syntax for tapply is tapply. You could use an aggregate. I don't actually, well actually I think tapply is fastest, but maybe it depends. Aggregate's another way you could do it. I just don't like the output from aggregate. So tapply, and then here, this is your analysis variable. Yeah, I know I'm using year, but you'll see what I'm doing. So this is your analysis variable in the first position. Your second position will be a grouping variable, or I will put vars. You could have more than one variable. If you have more than one, you need to use a list. And you can always email me if you're interested in that. Okay. And then the third thing is whatever function you want to apply to the analysis variable. And I'm choosing length, because all it's going to do is count for it. That's what length will do. Length is one of these very handy functions. Right? So all that's going to happen is we're grouping it within district. I'm going to count up. In other words, what is the length of the year vector? In other words, what is the length of how many crimes are there? Because each one of these rows are crimes. And then I'm nesting it within a coercion for a data frame. I want it to result in a data frame. And I'm going to say with district crimes, this is what district crimes looks like. Okay, so I just renamed some things. If you just do this first slide, it will result in some very ugly names that basically look like the commands you issue. And so you can rename. Renaming, there's no rename command in R. You take the names function, and it tells you what are the variable names in your object. And initially it was this. Okay, that was the name of my variable. And I renamed the number of crimes. So I asked for the names. It showed me that basically it copied the command I used and made that the variable name. Not something you want to be typing in at 4 in the morning. So you rename it, issue a names again, but this time it gets whatever you gave it. All right? If you had more than one variable, you would obviously use a C, like you could combine or concatenate and just list out your variables. And that's how renaming works. Remember, I always want just one pass of the data. In this case here, notice what's happening. I would like the police district to exist, because it actually doesn't exist. It's being saved as row names. So if you were to take a look at this data, this is something you can try if you think you'll be aggregating. You can take a look at the row names of the data set as created, and you'll see it's basically the districts. I'm going to save it to a new variable called police district. So it's just adding additional column to this. Otherwise, this was one column and row names that were police districts. But I'm extracting it and saving this new variable. And now I just take a quick peek. That's what you're seeing on the screen here. So aggregating data, this is how I might get a count of crimes per district. You can use TApply to compute means, medians, whatever function works. And you can pass options to those functions. And you could write lengthened functions in there. I'm just keeping it simple. This would actually be handy to maybe have counts in your aggregation. Okay? Questions on TApply?
What's the difference between TApply and
And sapply? TApply will return basically something that looks like a table. It returns a list. And a data frame is a subset of lists. So what TApply returns is a list. It actually looks rather table-like, and I can easily convert it to a data frame. sapply is going to return a vector. Okay. And so you could use that too, but I'll say this is kind of handy. It's going to aggregate. It's going to make things easy for me. So then finally we're at the match merge. And this is the end result, okay? So here's my, I don't know why I don't have the right code, I can have the next slide. Okay, end result would be I have the school data, and I'm matching it on the police district, and the number of crimes then is showing up as the last column, right? So I think I kept the merge on the next page. Here's the code for the match merge. So I've read into school data, and I'm subsetting right away. Right, so I saved the original read. Notice, schools gets read.csv. I could have saved it to disk outside externally, but I'm just leaving it in memory. It's not that big of a file. And I'm only going to keep, say, 5 columns of it, but all the rows. I'm going to save it to my school. My school has 566 observations, 5 variables. Okay? So notice one of its variables is police district. I just walked through this one with you where I created a data frame that by district totals the crimes. And then this is the final command. We merge data set X, data set Y on a key variable, which is the police district, and we'll get our new data set. Right? That's a match merge. The steps, you've got to have it visualized in mind. It's really important to have a unique identifier, something that identifies a transaction or something that you could treat as unique. Okay. Let us talk about splitting. This one, I'm just generally making a sample size. All right, here's a 50% sample. And I'm just going to say, okay, this is what I want as a sample size for my schools. And I'm going to set the seed to make my partition reproducible. Sorry, typo. But in other words, I'd like to pull 50% out and leave the other half available for another purpose. I set a seed, and then here I'm going to sample, and I just want to know, I want the number of rows in my school, and the length of that, right? My size for a sample is going to be the sample size that was created earlier, and I just take a look. So these are the rows that were pulled from my schools. Now, I can create a test data set. This one's fairly straightforward. I just say, okay, my schools, I want to, it should not have train in there. So let me back up. It's just a sequence of values that are being stored in train. So in other words, it's just think of the numbered rows. And I want to omit them if they're in train, so I'll call the other one test. And now this one actually has variables in it. It's a data frame. We can take a look. Test looks like the following. Train 1, here I'm keeping it if it was present in trains. It's just a way of splitting it. There are lots of ways to do that. I actually don't know what works best under the situation that you'll be in. And then, boom. Okay, so I've split it into, there should be no overlap. So that may be something you have to do. I'm going to show you another way of splitting, but these are my, what time is it go? Oh my goodness, I'm a lot faster. I didn't realize you had this running till 8. So. Okay, let me give you some closing thoughts, let me give you some extra, and then I'll open up to your specific questions, okay? Okay, there are packages out there that are 10 times faster than the things I've demonstrated tonight. dplyr, tidyr, and there's data tables. All right, I should write that in there. So there's package data tables, package dplyr. They're about 10 times faster when I've timed them than what I've shown you, okay? I was just not ready to give you a lesson in those, so that's not what I use. I know some of you use it and you're quite good at it. I posted some cheat sheets for data tables and dplyr to the space that Spencer set up where the data sets are, and you can take a look at those if you're going to do like a crash course in 2 weeks of this. I really feel that you should use what you're most comfortable with, because, you know, when it's 2, 3 in the morning, you don't really want to be learning new software, okay? All right, so what you want to do is, I would like you to consider splitting or sampling your file as soon as possible. So once you get it read and you know it was read right and you've saved it, and only work with a smaller subset until you're ready to test your ideas and you're doing the competition. We also want you to enjoy yourselves. Okay, so let me talk to you about split and sampling, because that's a key of people who work with really massive data, like, you know, their data sets are like 200 million observations. What do they do? You would need to split it, and you should probably do it in your Unix shell command. So if you're in a Mac, this is what I would suggest you do. All right. There's a terminal app on a Mac. I can show you, but it's under like utilities. It's terminal.app. Right? It allows you to work with shell commands and interact with files. And these are much faster than R. Think of it as stripped down, no overhead type of computing, the way it used to be done. So in this example, we can examine the size of the crimes data set and then split it using sed, which is just a Unix type of command. And we're not going to print out the output, and we're going to extract rows 100,000 to 200,000 and quit from the original data and save it to crime CSV. All right, this can all be done. Let me give you an idea, if I can find it. You got to find it. The messiest desktop in the world. Under applications, somewhere in here, is utilities. And somewhere in here is a terminal app. And this takes you inside your computer, in my mind. This is where the interesting stuff happens, down in here. And so, for example, some commands work and it tells you what's going on. And you just have to know old-fashioned computing to see what's going on a hard drive. Okay, so that's what I mean by the terminal app. Okay, so let me read up. So in that little window, this is all I did. I asked LS is just give me a list of the directory, and CR stars is anything that began with CR. So here I can see my crime data. Some on my desktop. I can probably do it for you now. Okay, so I'm on desktop. So I can say LS CR star. Oops, C lowercase. And so there it is, right? And then here, let me flip back. Okay. This is the word count. It's just going to give me some estimate of size. Word count -L says how many lines. So it's like, how big of a data set am I looking at? So I'm not thinking of 5 million. 5 million is not that big nowadays. I'm thinking of like 500 million. Okay. It can sit on your disk, but you couldn't read it all in the memory and all. So word count -L says, give me the lines of this file. And what comes out is there's 5,485,373 lines. Okay. So what I'm doing then, sed are these nice little commands that can be used to, this one can be used to specifically target a certain area of the file. There are a couple of other ones. Sed-n means don't show me this on the screen. Okay, basically it should be quiet. So it's going to go through my file, it's going to go to line 100,001 to 200,000, I think P means a quit out, I don't remember now. To grab those lines from my file, and it's going to pipe it or save it to crimes baby CSV, right? And then I can now look at a word count just to check it, and it's exactly 100,000. So I've got this smaller set. Now I'm not sampling on it. That's one of the weaknesses of this. On the other hand, what people typically do, like professionally, if you had, let's say, a 200 million row file, all right, that you had to work with, you might cut it up into size 10 million each or something more manageable, something that you knew that your resources could handle. And how you would chunk it up is not, this is like a perfectly fine method. You might say 1 to 10 million and then 10 million on 1 and so forth to make this smaller chunks. So you would chunk up an extremely large data set using somewhat different tools than what you have. I don't know what you're facing. I don't think we would have agreed to something that would crash everyone's computer. So I think it's going to be manageable, but just in case. All right. Those are extra shell commands. All right. It is early. It's much earlier than before. So I will say, if you want to let people go, that's fine. Otherwise, you can open the floor to questions, and I'll stay here as long as you need me to. Okay?